Find the minimum diameter of a steel wire with which a load of 50 kN can be raised so that the stress may not exceed 125 megapascal. Find the diameter chosen and also find the extension of the wire. If it is 4.5 meters long, take E is equals to 2.1 into 10 to the power of 5 Newton per mm square. So in this question, we need to find the diameter of the steel wire, minimum diameter of the steel wire with which a load of 50 kilonewton can be raised. This is stress strain problem. First of all, note down the given data here. So here, a steel wire is subjected to a load of 50 kilonewton. So generally load denoted by P. So P is equal to 50 kilonewton. So let us convert it into newtons. So 50 into kilo means 10 cube, 1000. So 10 cube Newton. Okay. Next given stress, maximum stress. Here stress is equals to, stress denoted by sigma is equal to 125 megapascal. So 125 megapascal can be written as, so 125 megapascal nala write Newton per mm square. Newton per mm square. Next, he also given that length of the wire. So length of the wire, length of steel wire denoted by capital L is equal to 4.5 meters. 4.5 meters. And Young's modulus. Young's modulus E is equal to 2.1 into 10 to the power of 5 Newton per mm square. Newton per mm square. So this is all about given data. So first of all, we need minimum diameter. Let us find minimum diameter. So generally diameter denoted by small d. We need small d. So here sigma is given and load is given. So what is the relationship between stress and load? We know the stress according to Hooke's law. Stress sigma is equal to resistance force by area or load by area. Load by area. So nothing but P by A. P by A. Area denoted by capital A. So area of steel wire. So area of steel wire. So what is the formula for area of steel wire? So generally wires are in cylindrical shape. So cylindrical shape lo untayi kabatti area emoutundi? Area is equal to pi by 4 into d square. Pi by 4 into d square. So this formula use cheyali, pi by 4 into d square. D is diameter of the wire. Now substitute this formula here. Sigma is equal to P by area pi by 4 into d square. Just simplify further. Reciprocal of pi by 4. 4 by pi. So 4p by pi d square. We need value of d. Okay, na? So here we need only value of d. And substitute remaining values. Here what is the value of sigma? Here sigma given 125 megapascal. So 125 Newton per mm square. So 125 is equal to 4 into load. So load 50 into 10 cube newtons by, so pi into d square. Pi into d square. Let us simplify further. Now 125 is equal to, so 450 is 200 into 10 cube by pi d square. Transpose d square to left hand side and 125 to right hand side. So division becomes multiplication. Division lo undi multiplication loki veltundi. So you will get 125 d square is equal to 200 into 10 cube by pi. Now transpose 125. So d square is equal to, multiplication becomes division, so 200 into 10 cube by 125. So let us simplify further. D square is equal to, so here you will get 200. So 200 into 10 cube, obviously you will get 2 lakhs by 125. Now simplify this. Okay, so 2 lakhs by 125. Your value is 1600. You will get 1600. D square is equals to 1600. Now d is equal to, we know that diameter is always positive quantity, so diameter is positive, so root over 1600. Apply square root on both sides. So diameter is always positive, that's why you consider positive square root. So d is equal to root over 1600, how much? 40. So d is equal to 40 mm. So minimum diameter of the wire is 40 mm. So next we need extension of the wire. So nothing but change in length. So extension of the wire ante ikkada change in length find out cheyali. So whenever a rod or bar or wire subjected to axial load, so then there will be a change in length of the wire or rod or bar. Okay na? So here we know that according to Young's modulus is equals to stress by strain, and here epsilon is equals to strain. Here bar subjected to longitudinal strain, so here strain means change in length by actual formula for strain is change in dimensions by original dimensions. But anyhow here wire subjected to longitudinal strain, so change in length by original length. So this is the formula for longitudinal strain. Okay, so epsilon is equal to change in length denoted by delta L by original length L. So in the question he given original length L is equal to 4.5 meters. Okay, now we have to convert meters into mm. Okay, now we have to maintain same units for every parameter. So ikkada mana same units anedi maintain cheyali. 4.5 meters can be written as 4.5 into 1 meter is equal to 10 cube mm. So 4500 mm. 4500 mm. This is the length of original length of the wire. Okay, so next Young's modulus also given. Young's modulus is equals to 2.1 into 10 to the power of 5 Newton per mm square. So Young's modulus is equals to stress by strain, and strain is change in length by original length. So reciprocal of delta L by L is L by delta L. So here we need delta L, so substitute remaining values. So here Young's modulus is given 2.1 into 10 to the power of 5 Newton per mm square is equal to stress given 125 megapascal, 125 Newton per mm square into, so length of the specimen original length 4500 mm by delta L. So Newton per mm square get cancelled. So now transpose delta L to left hand side, division becomes multiplication delta L. Transpose 2.1 in 10 to the power of 5 to right hand side, multiplication becomes division. So delta L is equal to 125 into 4500 by 2.1 into 10 to the power of 5. So units, change in length units obviously mm. Units will be mm, millimeters. So delta L is equal to, let us simplify this. So 125 into 4500 by, so 2.1 into 10 to the power of 5. So total we have 5 zeros. So we have to move this decimal point. Any decimal places move cheyali? 5 places. So 2, 1, we have to keep 4 zeros. So 2 zeros get cancelled, and 125 into 45 by 2100. Let us calculate this value. We will get change in length వస్తుంది ఇప్పుడు దీన్ని సాల్వ్ చేస్తే. One two five into 45, so answer 5625. 5625 divided by 2100. 2100. So change in length 2.67 mm. Okay, so change in length of or extension of the wire is nth extend in the wire 2.67 mm. Delta L is equal to 2.67 mm. So this is the final answer.